Okay, this is another review video. And for this particular one, we're going to be looking at the law of sines and cosines when it comes to applications of triangles. Everybody loves triangles. Okay, so if we look at our nugget sheet again, you see these are sitting over here on the triangle relationships, right triangles, oblique triangles, and law of sines, law of cosines. So let's sort of couch this in terms of application. Suppose we had a tower. We'll sort of make this first one pretty simple. We have a tower. We don't know how high it is, but we do know that it's casting the shadow. So let's see, the sun, we'll make it red. This is the bright sun up here, and the sun is casting a shadow on the ground, and we know the length of the shadow. The length of the shadow is, let's say, 33 feet, and we are told the angle of elevation of the sun, that's sort of an important word. This is the angle of elevation measured from a horizontal, is 67 degrees. Okay, so this angle, again, this is a horizontal line down here, so imagine horizontal line, this angle is 67 degrees, and the task is how tall is the tower? Well, if this is level ground, this is a right angle, so we can just use our right triangle relationships. We're looking for this side, which is opposite. We know this side, which is adjacent, so that screams tangent. The tangent of 67 degrees is going to be opposite over adjacent. Okay, opposite over adjacent. So the height of the tower will be 33 feet times the tangent of 67 degrees. 67 is not a standard angle. So that says use your calculator. Just pull up your calculator. Now, because we're working in degrees, you need to make sure that you're in degree mode. So I can just type all that out, 33 times the tangent of 67 degrees. Okay, so the tower is approximately 77.743. Okay, so 77.743. Make sure you carry the units with it, feet. Okay, so there's a right triangle. Now suppose it's similar problem, but this time the tower is on a hill. So let's say we have make a little bit more room here. We have a slight hill. We still have a tower. We still don't know how tall it is. That's our task. And we still have the sun shining at, here's our sun up here. And the angle of elevation of the sun is still going to be 67 degrees. Let's leave that the same. So this angle here is 67 degrees. And this time we measure the shadow. And the shadow is, let's change our units. Let's say this is 47 meters. 47 meters for the length of the shadow. And we have one other piece of information given to us, that this hill, perfectly straight line, but not horizontal, this hill has an angle of 10 degrees. So this is a fairly steep slope, a 10-degree slope. And this is the information given. Okay, and the task is to find the height of the tower. Now, parallel lines, so a little bit of geometry. The horizontal here and the horizontal here are parallel. And in fact, here's a horizontal right here. All of these are parallel, and we have equal corresponding angles. So if we look at the angle from the horizontal up to this line, that has to be 67 degrees, but we have this little wedge in our hillside here, and this wedge is given to be an angle of 10 degrees. So that means the net inside the triangle here is only 57 degrees. Okay, so let me pull that information off to the side here. This is what we're looking for. We do know we have an angle like this, 57 degrees, and we know the shadow length is 47 meters. Okay, we still don't have enough information the way I've got it drawn here, so there must be one other piece of information, and that ties in to, well, we can do it a couple of ways. We need to get one more angle. We either need this angle or this angle. And again, we're going to be using the fact that we have horizontals and verticals. The tower is vertical. Okay, so let me look at our angle of elevation again. This is 67 degrees. So this is 67 degrees. And if I go straight across this way, this would be 67 degrees. And because our tower is vertical, we know that these two angles up in the corner would be complementary angles. They have to add to 90. So this top angle is going to be 23 degrees. Okay, 23 degrees. Okay, now we have a pair of angles, and whenever you have two angles, that is a law of sines problem. Law of sines. Okay, notice that 23 degrees is opposite the 47 meters, and H is opposite the 57 degrees. So we're going to write down our law of sines. So we have H divided by the sine of 57 degrees is the same as 47 meters divided by the sine of 23 degrees, and just solve for H. H is 47 times the sine of 57 degrees divided by the sine of 23 degrees. And again, the units will be meters. So that's our answer. If we want a good decimal approximation, we can just go to our calculator. Again, checking to make sure I'm in degree mode, still in degree mode. Okay, so the height is going to be 47 times the sine of 57 degrees divided by the sine of 23 degrees. Okay, so the tower is about 100, 881. So the height of the tower is about 100.881 meters. Okay, fairly tall tower. Some radio tower, I suppose. 100 meters, that's about 330 feet. Wow, 330 feet. So about the height of a 33-story building. Tall tower. Okay, so one more triangle problem, and we pull up a new page for this. Let's suppose we do have a tower. Okay, so let's do another hill problem. We have a tower, and our task is to find the height again. This time, we know the length of the shadow. So the sun is still up here in the sky, and there's a shadow on the ground. And the length of the shadow is 80 feet. 80 feet. And let's say for some reason, we know that there's a guy wire holding the tower. A guy wire is basically a support wire. This is a wire, and we're told that this wire happens to be 100 feet long. Okay, and for some reason or another, we know this angle. This angle is given to us, and that angle, let's say, is 32 degrees. Okay, and that's all we know. We don't know the elevation of the sun. We don't know the slope of the hill. We just know this information here. Okay, so if you look at the two sides and the included angle, this is a side angle side problem, and that requires the law of cosines. Okay, law of cosines, we know that c squared is a squared plus b squared minus 2ab cosine of the angle between a and b. So I'll go ahead and call this a, and I'll call this b, and I'll call this c. Okay, so we have h squared is 100 squared plus 80 squared minus 2 times 100 times 80 times the cosine of 32 degrees. So h itself is going to be the square root of all that. 100 squared plus 80 squared minus 2 times 100 times 80 times the cosine of 32 degrees. And at that stage, I'll just go straight to my calculator and let the calculator do all the work. We have the square root of 100 squared plus 80 squared minus 2 times 100 times 80 times the cosine this time of 32 degrees. Okay, so the tower is approximately 53.209. And what were our units? Our units were feet. 53 feet tall to the nearest thousand. Okay, so there's a right triangle problem, a law of sines problem, and a law of cosines problem dealing with triangles. Just as an aside here, I'm thinking about exam. We're going to let every person bring a 5 by 8 card or sheet of paper, if you will, that can have any formula on it that you want, formula or equation. And you'll be able to use that for most of the exam. There will be, I need to caution you here, there will be one section of the exam. We'll do this at the very beginning. There'll be a page, one page, which is just unit circle information. Unit circle information, like we did way back on one of the earlier videos. And for that particular one, you do not have your card. So make sure you know that information memorized by cold. Memorize it cold so that you know it by heart. So, you know, if I said, what is the cosine 45 degrees, that should not be something you look at on your card, or what is the tangent of negative 30 degrees. Don't look on your card. Or what is the secant of 7 pi over 6. Again, you don't look on the card for these types of problems because you won't have your card available. But all the other information, you know, this formula equation, you can put any identity that you want. You can put formulas like the law of sines or the law of cosines. You can put your arc length formula, your sector area formula, anything like that is fair game. Okay, so let me stop this. This is about 13 minutes.